This is an example of how to prove a trigonometric identity. The goal when you're proving trigonometric identities is to prove that the left-hand side and the right-hand side are exactly equal. Now this is different from an algebraic equation. We're not solving for x. We're simply trying to prove that no matter what value x is, that the left and the right-hand side are equal. So one of the ways that you can get started is, well, first of all, you need to pick which side you're going to start with. And I always say, let's pick the most complicated side because that gives us more stuff to work with. So then once we've picked the side, and it looks to me like the left-hand side is more complicated than the right, one thing you can think about doing is see if you can rewrite everything in terms of sines and cosines. Sometimes that will lead you to the end. And if it doesn't, well, at least it will get you started. So I'm going to substitute using the quotient identity, and this quotient identity is sometimes called the reciprocal identity, and that is that the cotangent is equal to the cosine of x over sine of x. So I'm going to replace the cotangent of x in my original identity with cosine of x over sine of x. Now the next thing I'll do is I'll simplify that and then figure out where to go next. So now I've multiplied the cosine of x times the cosine of x over sine of x. Now you might be scratching your head and thinking, well, what in the heck can you do with that? Well, one thing I might think of, since I have a fraction in there, the cosine squared of x over sine of x, maybe I could make sine of x into a fraction and then add the two fractions together. So to do that, I would find a common denominator. So remember that sine of x, we could always represent it as sine of x over 1. And I want to transform that into something that has a denominator of sine of x to match the cosine squared of x over sine of x fraction. So I multiply by sine of x over sine of x, and I end up with sine squared of x over x. Now I have two fractions, and I can add them together because there is a common denominator. So I add the fractions by adding the two numerators together and putting that over my common denominator. Now I'm hoping that that numerator will look familiar to you. Sine squared of x plus cosine squared of x. Does that ring a bell? Well, it hopefully will ring the bell that it is the Pythagorean identity. Sine squared of x plus cosine squared of x is equal to 1. So now I can substitute a 1 in there, and I'm left with 1 over the sine of x. And now if I look back up at my original identity that I'm trying to prove, and I look at that right-hand side, I see it's supposed to be the cosecant of x. Well, guess what? 1 over the sine of x is actually the same as the cosecant of x because that is a reciprocal identity. So I make that final substitution, and now I have proved that my left-hand side is equal to my right-hand side. So before I finish, I just want to give you a few little tips and warnings here. And you might, keep this by your side as you're trying to prove various identities. So your goal, keep in mind, is that you want to prove that one side equals the other side. And remember that these are not equations we're not trying to solve. So you simply start with one side, your choice, discard the other side for the moment, just to get started, and then start trying to substitute in various equations. Now, I always tell students, as I mentioned before, if you start with the most complicated side, that gives you more stuff to work with. Knowing the trigonometric identities really helps if you haven't memorized those fundamental identities yet. At least have a cheat sheet next to you that you can look down, and sometimes that will just trigger ideas about where to get started. As we've done in this example, sometimes when you rewrite everything in terms of sines and cosines, you can really get somewhere. Sometimes you need to combine fractions with a common denominator, and we did that also. Sometimes you'll have a complex fraction and it helps to break it apart. Sometimes you may have to factor, so you may have to remember some of your algebraic methods that you used when you were learning how to factor. And there's often more than one way to proceed, so there isn't a single right path. Now, sometimes the way that you choose to start might not lead you to the answer. You'll hit a dead end. Well, that's all right. Just start again and try to start down a different path. And finally, sometimes you can work both sides. So sometimes you'll take the left-hand side and you'll work it down for a while and then you can't see how to proceed. And so you stop and you say, okay, well maybe I should start with the right-hand side, and you work it down. And all of a sudden you realize you've worked both the left and the right-hand sides down to the same point, so they are actually equal. Well, that's not exactly a formal proof, but at least this will show you which way to go. So that's it, tips and tricks plus the example.